Hello, everybody, and welcome to our webcast today, Heat Sheet Radiant Floor Panels 101. My name is Andy Lennox. I'm the president of Logix Brands, and I'll be conducting the majority of the webcast today. Um, Francis Roma, our technical director, is also attending. He's here to help if there are any questions and such of a technical nature. And we'll tend to, you guys on your control panel, if questions do come to mind, feel free to tap them in. And throughout the short presentation, I think our presentation will be about 20 or 25 minutes. And we'll answer any and all questions at the end. And we also received a couple of questions in the registration process, and we'll deal with those at the end as well. If we don't get to all the questions, and sometimes we can't, we'll circle back afterwards and reach back to you directly. So with no further ado, let's get rolling. So this is, as I said, I'm the president of Logix Brands, and this slide explains Logix Brands. Logix Brands is a consortium, and here it's a consortium of expanded polystyrene manufacturers, and this is a map showing the location of the members of our consortium and where they're located. And these EPS molding plants got together to form a consortium to develop and bring to market a series of engineered insulation product lines. And engineered insulation products are insulation products, quite simply, that are shaped. They're not just flat, regular insulation products. They're shaped, they're modified, and they're enhanced in some way. And they're done so in a manner that help builders lower the cost and increase the speed of construction while helping them build buildings and homes that are more durable, efficient, and comfortable to live in. So adding performance and increasing efficiency is all about the nature of our engineered insulation products. Here are the four brands of engineered insulation products that we go to market with: Logix, Halo, Heat Sheet, and Chrome GPS. And today we're going to be talking about the Heat Sheet product line. So here's a picture of Heat Sheet, and we'll dive right into it quite shortly. You can see that it's certainly not a flat regular insulation product. It has been enhanced and shaped and molded, and we'll get into all the various advantages that Heat Sheet brings to the table. So here's our agenda today. It's going to be about 20 minutes, 25 minutes, so we'll move pretty quickly. Product line overview. We're going to cover key design features and benefits. We'll do a case study. We'll talk about the difference of expanded polystyrene and expanded polystyrene. So to get into that level of conversation, we'll talk about resources available to builders and dealers who work with Heat Sheet. And we'll talk a few about some insider tips, and we'll do, as I mentioned before, the Q&A at the end. So let's get rolling. First, I just want to give you a bit of a caveat. We're not at Logix Brands, we know our products and we know what they do, and we're experts in engineered insulation products, but we're not experts in radiant floor heating. We're not HVAC designers, and we're not HVAC installers. So we can certainly talk about how our products fit into the process, but in terms of the overall radiant floor technology, we can answer certain questions to the best of our ability, but we're by no means experts in it. And I just wanted to qualify that. So let's just get started. You can see here's the basic premise of Heat Sheet. It's a panel. It's got a track system molded into it, and you can see the Heat Sheet products being laid down on a job site. And you can see the PEX piping for hydronic radiant floor heating. The PEX piping is actually laid into these grids, which create preformed channels that the piping can nest into and get secured into, and they're held in place, properly spaced, for a layer of concrete to be poured over, which once the building's completed, that concrete is heated and provides great comfort to the building. So that's the nature of the Heat Sheet product line. There's two main components of the Heat Sheet product line: our flagship Heat Sheet product and Heat Sheet Heavy. And there's a lot of commonalities between the two. There are some differences, and we'll get into that. So let's get into the very basics of heat sheet. So heat sheet is they come in 4 foot by 2 foot panels. You know, we picked that panel size because we thought you could have made it bigger, you could have made it 4 by 4, you could have made it 4 by 8, you could have made it smaller, 2 by 2. We thought that 4 by 2 was just the perfect sweet spot for us and for our customers. It's easy to handle. One person can pick up a bundle and move it around, and yet big enough so that when you're placing a product, you're placing enough square footage to make it an efficient process. Now, the nodules are 3 inches in basic heat sheet, are 3 inches in diameter, and they form a grid pattern that's 3 inches on center. So the channels are 3 inches apart all throughout. Now you'll notice that the panels do have an interlock right here at the edges. So the panels do interlock together and seal together. These in terms of the strength or the compressive strength of the foam, heat sheet panels come in a variety of compressive strengths. The minimum compressive strength that they're available in is 20 psi, pounds per square inch. Most of the time, they're available, or often you'll see heat sheet offered at 30 psi and can be actually custom ordered to much higher compressive strengths, up to 60 psi for higher durability situations. And they're available in R4 from a thickness of R4 to R20 and plus. So I guess that's one of the inherent differences of heat sheet when you compare it to the other types of radiant floor panels out there, is the variety and depth of the product line. Varieties of a compressive strength for the application, a variety of R values available, not just one or two standard offerings. Now, the basic core heat sheet panel, it comes into thicknesses from a minimum of R8 to a maximum of, I guess, basically R20, although you can, from some plants, order them, if you wish, at thicker, but for all intents and purposes, let's say they go up to R20 on an off-the-shelf basis, and they're designed for regular under slab applications in homes and buildings. And I'd say probably it's our residential product line, although it can be used in commercial applications. And there's a picture of it in action there. Now, the thinner panels, thinner than R8, they're R4 and R6. And we kind of call them our retrofit panels because they were designed not so much for providing exceptional R value. They were designed to be thinner so as to conserve ceiling height if you're putting them into already constructed slabs or floor systems, and what your primary concern is at that point, you want to install your tubing, you want to provide a bit of insulation backing and give it a basis for the tubing to nest in, but you want to conserve ceiling space, head space, ceiling height at all costs. So that's what these are designed for. And when you get to this thin profile, you can see that, of course, it's too thin to have the interlock, and so it's thinner and it doesn't have the interlock. And although we say it's designed for retrofit primarily, I mean, we actually used it, one installer used it actually in a brand new multifamily assisted living facility in British Columbia. These are cast in place concrete floors, and they were spec'd to be radiant floor heated, and the cast in place floors were already in set. The installer had to maintain ceiling space and headroom, and so just found a way to use what we would call our retrofit panels in a new construction situation. So it's always a case of you design something for a particular use, and then lo and behold, installers find different ways to use it out in the field. So let's talk about heat sheet heavy. So we've talked about retrofit panels, we've talked about regular heat sheet. Now let's talk about heat sheet heavy. So there's a picture of regular heat sheet. Here's an image of heat sheet heavy. So comparison wise, heat sheet heavy has the same nodules, but they're 4 inches wide as opposed to 3 inches. And they're deeper. They're an inch and a quarter high, the nodules, as opposed to 7/8. So it's a wider nodule. It's high. It tends to come in higher density EPS. And while regular heat sheet accommodates 1/2 inch and 5/8 inch pipe, um, heat sheet heavy will also accommodate 1/2 inch and 5/8 diameter pipe, but it also accommodates 3/4 inches pipe, 3/4 inch diameter pipe for more commercial applications, heavier duty applications. So that's where we get the name heat sheet heavy. It's for more commercial, more heavier duty applications typically. And here's a commercial application for heat sheet. So a large slab with heavier loads, perhaps trucks, perhaps heavier loading conditions on the slab, and often used actually in driveways for snow melt applications. So not inside the building, outside the building, used in sidewalks and walkways and patios and driveways and parking lots to melt snow externally. So, what's the basic value added premise of heat sheet? And there's a few of them, but it all starts and revolves around time and money savings. And vast majority of the money savings and time savings comes in the actual installation of the PEX pipe. And we often say that HVAC installers who use heat sheet radiant floor panels never go back to the quote unquote old way. Here's the old way. The old way is flat stock installation, laid down, no track, no grids, no nodules. The rebar is laid down over top, and then as you can see, the tubing is the crew has to determine the appropriate spacing, and then they tie the tubing at about 1 foot increments all throughout to the rebar. It's a very manual process. It's rigorous. It's hard on the back. It's hard on the knees. You can get it done. It works. It's effective, but it's not easy and it's slow. And conversely, this is the way many installers install heat sheet or PEX pipe into heat sheet. They walk it in, and then they just walk it in standing up and just walk it right in. And so it's much easier and much faster, and it saves a bunch of money. So other interesting facts. There's no need to protect. No, you do have to protect. I mean, radon gas is a concern out there. It's an emerging concern, and it has been for a while, and it's going to be. Now, there's areas of high radon and there's areas of lower radon. And if you're in a situation where you're in a high radon area and you do want to protect against radon and provide a radon barrier, you still need a layer of poly underneath heat sheet. Okay, so that's heat sheet does not classify or qualify as a radon barrier. Okay, however, if your heat sheet meets or exceeds 25 pounds per square foot in compressive strength, and if it exceeds R10 in diameter, then there's no vapor barrier. Poly vapor barrier is required for heat sheet. So you could just lay heat sheet down on your gravel bed. Okay. Now, and if it's properly interlocked and the perimeter is sealed, there's no taping going to be needed because the panel's interlocked together, except if you have any cracks or broken lap joints, you've got to apply tape there. But so you can avoid the time and expense of vapor barrier with heat sheet due to the interlock. So that's another time savings. However, if you want to protect against radon, you're going to have to use the poly. And there it is. I mean, let's just talk about the piping walking into place fast. And the other interesting thing here is some other different products, radiant floor panels. They may have different nodule designs. Some of them can be what we would call pucks, named after hockey pucks, round. They can be round. Heat sheet's not round. It's got this certain layout here. And the reason we've got this layout is it's designed so that each nodule contacts the pipe twice. And you can see that happening here. If these were round, they'd be contacting the pipe once. So 2 points of contact per nodule means twice as many points of contact with the pipe, which means a stronger friction fit, a more secure fit. So staples the heat sheet then typically, the PEX pipe typically stays in place. Staples, and these are the little staples here, and they can be used, but they're typically only needed with heat sheet at the bends, not so much on the straight runs, which is the vast majority of the length of the piping. So let's take an opportunity now to show a quick video and to show how heat sheet works. And I'm just going to caution you, there's a little bit of soundtrack to this video. You might feel the need to turn your volume down. Okay, so there you go. You get the idea. So that little video, it showed you the interlocking. It showed you basically the bundles that it comes in and how they're easily hand bombed. Shows I thought hopefully the speed and efficiency of installing it, and also the methods by which installers walk the pipe in. So that's just a little bit of an overview. Listen, job sites are not for the faint of heart. They're rugged. Places. There's equipment, tools. So you want your products to be durable, and that's why we designed heat sheet to be at higher compressive strengths. The panels are very durable. They resist breakage, and every time you break something, it's a needless waste of time and materials to replace it or tape it up or replace the material. So heat sheets designed to resist all of that. Here's a couple of testimonials from some builders. So this is Travis McDonald Plumbing and Heating in Manitoba, and on the PEX pipe, he's saying they're laying between 8 and 10,000 lineal feet per day with two guys, with two crew. And whereas with the old system, they'd be laying down between 3 and 4 guys, so double the labor, about 5 to 6,000 feet total. So we're possibly doubling footage with half the crew. So that's 4 times faster. And give you another quick video clip from another installer.
Brendan Benoit with Meridian Plumbing and Heating, laying down some heat sheet and some infloor. Favorite part? Definitely walking it in. That ease of installation compared to rebar, off the charts. I've only installed in-floor heating on rebar. This is night and day compared to that. Tying everything down every 1 foot as compared to this, just walking it out and clicking it in. This is a knee saver and a back saver.
So there you go. Let's get into now why heat sheet panels are made with expanded polystyrene. Why did we choose EPS? And what are the benefits of EPS versus XPS, which is a very popular competitive line of insulation. And for this discussion, I'd like to bring in Francis. Are you there, Francis?
I'm here.
All right, Francis, can you just take everyone through quickly some of the main benefits of EPS versus XPS?
Okay, so I'm going to compare EPS with XPS, and we're going to talk about water retention or water absorption, because I think that's where it gets compared most of the time. So there's this misconception out there that because EPS does have a higher water absorption than XPS, that you can't use it for certain applications, specifically potentially wet environments. It's true that EPS does absorb more water initially because of its higher permeance, but because of its higher permeance, it also allows that water to escape just as easily. So it actually does a good job at retaining its R value, better than XPS does because it does have a lower permeance. Unfortunately, the standard test for water absorption is based on short-term testing. So it only requires small samples to be immersed in water for up to 5 days and then immediately measured for water absorption. The problem with this test, though, is it doesn't actually tell you how much water is still left in those samples after a month, a year, or even 2 years from now. So it's not really indicative of real world conditions. It's meant for quality control purposes, and it's not meant to represent end use conditions, this test standard. And it actually says that right in the standard itself. So, but these are the properties that we have to report to make public. And I think designers see these values and they just come up with the conclusion that it's supposed to represent end use conditions when it actually doesn't. But what we do know from independent testing is that there are long-term effects of R value due to water absorption. We know that EPS retains less water than initially absorbed, and that's because of its higher permeance. So because of its higher permeance, any water that does make its way in there over time can get out just as easily. So it maintains its R value. With XPS, it retains absorbed water longer, and that's because of its low permeance. So any water that does make its way in there long term actually gets trapped in there much longer because of its low permeance. So as long as the water is sitting in there, it's reducing its R value. There was one study where samples were buried for 15 years. It showed on average that the XPS samples had 19% water absorption and retained only 52% of its R value. With EPS, it retained 5% water absorption, or had 5% water absorption and retained 94% of its R value. So this is all indicative of the permeance properties of these insulation materials. What does this all mean? It basically shows us that EPS actually does a good job at retaining its R value, better than XPS can, especially in potentially wet environments.
Well, thank you very much, Francis. And so in summary, I mean, heat sheet, what it basically does, it's going to, rather than a flat XPS panel, it'll retain its R value longer and will actually save you time and money saving for installing the PEX pipe. So that's the basic value proposition in a nutshell. One other thing, embodied carbon and global warming is a concern for many, many people. And there's a growing movement to use building products with lower embodied carbon than those with higher levels of embodied carbon. And EPS, one other advantage of EPS is it does have less embodied carbon global warming potential than comparable XPS products. So the EPS products are kind of all over the map. This is the measurement of GWP, embodied GWP. So as you can see, depending on how the XPS is made, it's from either 5.39 to 41.09. The EPS that we use in heat sheet is lower than the lowest and up to 10 times or 9 times lower than the highest. And it's all got to do, I think, with mostly with the blowing agents that are used in the XPS product. So it's less, in addition to everything else, lower global warming potential, less embodied carbon. And one other thing, the new XPS has gone through different iterations. It had to, there's been regulations come out because of the high global warming they had to change their manufacturing processes. It turns out that this new manufacturing process does have somewhat lower GFP, but it tends to use 15 times more fresh water in its manufacturing process for some reason. And so that's an incredible amount of fresh water to be used in. And so it's another reason to consider using EPS is the conservation of fresh water. Anyways, on to available resources, next part of our topic here. So installers and dealers who handle heat sheet, there's installation guides available. And by the way, our basic heat sheet installation guide is attached to your control panel in the handout section. So if you'd like to download that, you can. There's also a heat sheet product information cell sheet that you can download as well if you wish. But there's also telephone and online support offered by our dealers and actually offered by our manufacturing plants. We have regional technical, at the Logix brands level, we have regional technical advisors available that can answer questions. We have a network of local stocking dealers that have a heat sheet ready to buy. Just walk in and pick it up. And you can find the location of those on heatsheet.com. There's a section on heatsheet.com. We call it our where to buy locator. Just tap in your location and you'll see the nearest manufacturing facilities or stocking dealers near you. Have trouble finding someone close, feel free to send us an email and one of our technical advisors will be back in touch with you. We also have a handy 1-minute estimator on heatsheet.com where if you just simply tap in the dimensions of your install, your slab, it'll quickly size up and tell you how many heat sheet panels you're going to need for your project. So, insider tips for your first install. So, we talked to an installer who had used heat sheet for the first time after having used XPS panels, having done it the old way previously. And so we asked this installer, well, what tips would you give for someone using heat sheet for the first time? What are little mistakes subtle mistakes that you made that you'd want to just advise people on? Tip number 1, take care when leveling. You don't need poly. You can lay your heat sheet directly on the gravel as long as you're not needing a radon barrier, but take care when leveling. If the ground is uneven, the tubing may not seat correctly and could end up popping, and you'd have to then staple it in and such. So just take care when leveling. Secondly, consider using PERT piping. We use PEX piping all the time as a slogan. It's like Kleenex, but there's other types of piping as well. PERT piping just has a bit more flexibility. It's softer, makes it a little easier if you've got more dramatic bends in your install. And also, in the winter, heat the piping with a heater during the day. If you're doing your PEX pipe install in January in a cold climate, don't just take the big spool out frozen. That plastic will be really hard to work with. So, have that piping heated with a heater during the day, and you'll be happy. Okay, keep foam staples nearby, even though you don't need a lot of staples in the run. Okay, in the straight runs, keep them anyways. They're good to have, especially if around the molded knobs and just in certain high traffic areas. Bring a sawzall. Around a sawzall can be very valuable with heat sheet. Keep it on board, especially where the manifolds. And the manifolds are where all the tubing comes down the wall and enters into the floor. And that can be kind of tricky here. And you've got to cut around the manifolding. So a sawzall is very helpful. And carefully order the concrete. One thing to recognize is with the heat sheets module or grid pattern, you're going to need about a 1/2 inch more concrete depth to get the same coverage as you would get on a regular flat stock of insulation. Okay, so to get for instance, to get a 3-inch deep slab, you'd have to use a 1/2 inch more concrete. So it's a bit more concrete that you're going to have to pay for an order. Now, compared to the labor savings and all the efficiencies, it's a great trade-off, but it's definitely something you want to keep in mind. You don't want to be short. And in fact, the heat sheet 1 minute estimator does actually give you concrete values as well. If you type in not only the amount of heat sheet product you need, but it'll give you it'll also ask you to type in the thickness of your slab, and it'll give you the amount of concrete, rough amount of concrete. Okay, so Francis, I'm going to ask you to hear the deal to talk about this. We had with heat sheet, the tubing is actually fixed towards the bottom of the slab by design, and it has been brought up to us at times. You know, wouldn't it be better and more efficient if the tubing was in the middle of the slab? So Francis, can you just explain the thinking here?
Sure. So we did get this question come up quite a few times. So we had some heat loss calculations done independently by a well-known building scientist. And what he's showing here is that for a 4-inch slab, when you have the PEX tubing at the middle of the slab versus the bottom of the slab, you increase the heat loss through the ground or to the ground by 1.6%. So you get more heat loss, only 1.6% if you got PEX tubing at the bottom of the slab versus the middle of the slab, which isn't a significant amount. If you want to reduce that even further, though, all you have to do is increase your insulation value, so increase the thickness of heat sheet that you're using. But also the other added advantage to having it at the bottom of the slab is if you're, you know, having to penetrate the slab for, say, a frame wall or something, there's less chances of you hitting a PEX tube than it would be if it was mid slab.
That makes sense. Okay, thank you very much, Francis. We're going to get into the questions now that we've received, and I'm going to use this as an example or a prompt to highlight our blog on heatsheet.com. So heatsheet.com, actually, we're going to be coming out in about, if you visit heatsheet.com in a couple of weeks, you're going to find that we're going to have a much more robust website. We're just in the final stages of launching that. So check back in a couple of weeks and you'll see a lot more resources on the website for heatsheet. But even now there's a blog section, and we use that blog to basically answer the most prevalent and common questions that come up in these webcasts and when we talk to installers and customers. So, you know, feel free, visit the blog. I think you'll find it very informative because I'm going to highlight it to answer some of the questions that have been posed in the registration process. So what does it cost? What does the whole thing cost? We actually give in this blog post back that we did in April 2021, we actually did an overview of the overall cost of hydronic floor heating in a typical basement. You know, listen, every region has different concrete costs and different labor costs, and certainly prices have changed a lot since 2021. There's been a lot of inflation, but it's a good guideline. Now, for heat sheet itself, depending on the thickness, you're looking about and what the dealer charges, you're looking about $1 as a rough ballpark, $1.75 to $2 per square foot for the heat sheet product itself. What piping should I use? Typically in residential, it's 1/2 inch or 5/8 is typical, but we have a great blog post that goes over the dynamics involved with PEX pipe sizing, and the factors that go into it. Why you should consider snow and ice melting. It's becoming increasingly popular. And we've got a series of blog posts on that topic. You know, is it right for you? Is it right for your climate zone? If it is right for your climate zone, how do you do it? If it is right for you, how much does it cost? So there's a whole bunch of content, but certainly yes, you can use this on your driveway or your sidewalks or your walking surfaces outside. And what's a radiant floor heating rough-in? I mean, this is an interesting thing. Like if you're a builder and you're doing spec homes and for the public, and you're looking for, you know, very cost-effective upgrades to offer your clients to differentiate your house versus the house next door. Um, you know, what we're seeing a lot of builders doing is what we call a radiant floor rough-in in the basement slab. So in other words, instead of just pouring a slab with regular XPS insulation and a regular slab, um, they'll put down some heat sheet, they'll put down the PEX pipe, which doesn't cost very much, then put down the slab, but they don't have all the connections done to the boiler, the hot water. It's just a rough-in, so that if the customer wants somewhere down the road to radiant hydronically heat their basement slab, they can hook it up. It's a brutal thing to have to do after the fact to install tubing in concrete after the fact. So it's a you know what, it's a very low cost and effective upgrade if you're building a new home. Okay. And that is it for our questions from the crowd. I do have a question here from that's come in from John, and let me just John asks, and Francis, maybe you can help. So, and I think we can help this. Francis, John's got an industrial shop heating application. Do you think this product would be suitable for a shop floor?
For a industrial shop,
Yeah.
for sure. I don't see any issues with that or why you wouldn't want to be honest.
Okay, so perfectly acceptable for that, right?
Yeah.
Okay.
Yeah.
All right. Well, everybody, that is the extent of the questions we've had. If you do, you're going to get a survey at the end of this. Feel free to tap in any questions that come to mind, and please fill in the survey if you can. We'd love your feedback. But we're at the end of it. Presentation. We want to thank you very much for spending your time with us. You're going to get a follow-up email with the survey, with a recording of this webcast, and we'll be happy to answer any questions. So, Francis, that's it. I'll give you the last word.
Sure. Thanks again, you guys, for joining us, and enjoy the rest of your week.
Thank you, everybody.